All right, so surface area of a cylinder. We've talked about surface area of a prism, surface area of both kinds of prisms that we dealt with, whether it be a triangular prism or a rectangular prism. But when we talk about the surface area of a cylinder, I mean, the idea is the same, right? Surface area, well, what does it mean? It means the area of the entire surface of a geometric shape. You could also think of it in terms of the area you would have to paint if you were painting an object, right? Generally, there's not a whole lot of challenge in terms of the concept. So when you're calculating the surface area of a triangular prism, how many faces? Well, we've got 2 triangles and then 3 rectangles, so a total of 5, right? 2 triangles and 3 rectangles, which may or may not be the same size. And so you sort of have to adjust your formula a little bit depending on if they're the same size or not. Worst case scenario, you have 2 triangles that are the same, and then you have 3 rectangles that are not. All right, so formula for the area of a triangle, we'll start with that one, is, let me draw it out here for you, area is equal to, we can write this a couple ways. The idea is base times height divided by 2. Another way you might see that written, so an equivalent way, would be BH over 2. All right, base times height, then divide by 2. That's your triangle, right? So that's these guys. And then at the end of that, if there's 2 of them, we'll multiply by 2. For our rectangles, area is equal to simply length times width, so LW. All right, so next step, all right, we've got a soup can here. And something went wrong as I moved stuff around. And that got a bit better. There we go. All right, so let's draw a net for this guy. We have 2 circles. Those will be not attached to each other. And then you have to think about, what about the side that's got, I guess, the label on it? If you peeled the label perfectly off, good luck with that. You can, I would also recommend don't go into, the cupboards at your house and find a bunch of random cans and peel the labels off. That's not a nice prank. I guess if then somebody's trying to make you food and you think you're getting tomato soup, and in fact it's like, I don't know, something else, it might be a little bit off. But anyways, assuming we've got this label and it comes perfectly off, its shape would be a rectangle. So if we take a look, there's one of the ends. So imagine we took the end off, left it connected right here, and we'll do the same thing on this side. We'll leave it connected right here. And here's going to be our rectangle. And I'm going to assume that circle is attached on the other side. Diameter of this circle, I'll leave you to label it, 7.5 centimeters, which means the radius is going to be half of that. So you should probably figure out what the diameter and the radius are and label those. You could do that on this side too, although they're both going to be the same. And then the question to ask yourself is, okay, where is this 11 centimeters? Is that from this end to this end, or is that across here? And I will tell you, it's across here. It's going to be 11 centimeters. That is not an 11. That's going to be our 11 centimeters. That's going to be our height. That's where the H was coming from. That's the height of our can. Now, this rectangle here, what about this length here? How long is that going to be? Because I have the diameter here, right? That's here. Well, once we realize and look at this, we're going to, oh, this is the circumference. All right? So your job right now, go into your cupboards at home, talk to somebody first to make sure they're not planning on using it in the next 5 minutes. You're not going to peel the label off, don't worry. Go into the cupboard at home, find a soup can or some kind of a can of something, and I'd like you to measure the diameter, measure the height, and then you don't have to actually cut the paper, but line the paper up, roll it around there like you were wrapping it, and just see how long is that piece of paper when you roll it all the way around, right? So essentially wrap up your soup can for a moment, just mark where it is on the paper, and you can figure out, okay, how long and how big actually is this thing? All right, once you're done that, we can move on. But I will tell you, this distance here to here is going to be whatever the circumference of the circle is. Okay, so if you think back to grade 7, you're going to find you found circumference. Circumference is equal to pi times the diameter, or let's try that again. Or circumference is equal to 2 times the radius, which gives us the diameter, and we'd write it as 2 times pi times r. Either of those will work to find the circumference. And now, if you think about the faces you have to figure out, we have 3. We have 2 circles, and we have 1 rectangle. Now, these are a little bit more complicated because the formulas have got squares and pi and whatever else in them, but the idea is not that much more complex than any of the other ones we've done. All right, so let's take a look here. What shapes must you find the area of to find the surface area of the can? 2 circles. And 1 rectangle. Lovely, that's not too bad. All right, how can you find the area of the top and bottom of the can? Well, it's a circle. Area of a circle, we know that formula. Area is equal to pi r squared. Now what that means is pi times the radius squared. If I'm putting that in my calculator, I am going to generally be lazy, and I'm going to say area is equal to pi times the radius times the radius. Right? And then I'm not messing around with trying to make sure I got brackets or that my calculator is actually doing order of operations. So if I look at this particular can, all right, the radius is half the diameter. Diameter was 7.5. All right, so pi times 3.75 centimeters squared. And away we go. I mean, really, that's the hardest part about this whole thing, is to figure that part out. Once you've got to that point, you're good. All right. We'll actually do the calculations later on, but if you can, right, you're using that formula, that's exactly what we're doing. Or again, pi times 3.75 times 3.75, because that's what the squared means. All right. Question 6, how do you find the area of the round section of the can? What's a rectangle? Area is equal to length times width. Now, in this case, right, usually with a cylinder, we don't call it a length and a width. We're going to call one of the dimensions, right, this is across our, when we had our rectangle drawn out here, right? We can call this if you want to call it the length, sure. That was the height, right? Height times, and we said this distance from here to here is the circumference. Height times the circumference. So we can make that a little bit better yet. We can say, okay, is equal to height times pi times d. Or if instead of d we want to have 2 times the radius, height times pi times 2 times r. And we would normally write that as the number first, and then pi, because pi also stands for a number. 2 pi r h. Okay, and this is where the 2 pi r gives us the circumference times the height. Okay, remember when we're multiplying, it does not matter what order we go in. All right, step the next. We're going to estimate the surface area of the can. Well, let's go back up here. Take a peek here. So, top here, 3.75. It's pretty close to, let's go with 4. 4 times 4 is 16. 16 times pi is about 3, is 48. 48 is pretty close to 50. Top and bottom, 50 plus 50. Okay, not so bad. So we got 50 for the top and bottom. Then the height, or the rectangle part. All right, so here we're going to have, well, pi times the diameter. So 7.5, pretty close to 8. Pi times 8, well, 3 times 8 is 24. 11, that's pretty close to 10. I am picking all numbers here that I can multiply pretty easily in my head. Okay, and so when I look at this, I say, okay, well, my top and bottom, estimating again, were, well, about 4 times pi. All right, so 4 times 4 was 16. Okay, so these are my circles. Oops. Area of my circles equal approximately pi r squared. So again, estimating 3 times 4 times 4, which is equal to 48. We're going to multiply that by 2 yet. So 2 times that is going to 48 times 2. Again, I am just estimating here, but I'm picking numbers that are nice. Equals 50. Right? No, let's try that again. 48 times 2 does not equal 50. 48 times 2 is 100. Right, approximately. 48 times 2 is actually 96. I'm rounding it up because then my adding gets easier. All right, then I've got my rectangle part. All right, so we've got area of the rectangle is equal to, well, pi times diameter. So we'll go with 3 times 8, which is 24, times the height, which is 11. We're going to say it's about 10. 3 times 8 times 10, I can do that in my head. 3 times 8 is 24, times 10 is 240. Total is going to be 100 plus 240. Oops, that's a lovely A. Area of the total equals approximately 100 plus 240, which is going to be 340 centimeters squared. Which means when I do the actual calculations, if I'm close to that, hopefully I did it right. If I'm wildly away from that, I better check something. I might have done something wrong. All right, so surface area of the can to the nearest tenth of a square centimeter. Area of, and I use a little subscript C, of the circle is equal to pi r squared. The area of the circles, sorry, times 2. Which you might also see written as 2 pi r squared. All right, which I'm going to say space is equal to, and I'm just going to write the pi. I'm going to punch 3.14 into my calculator. Pi times 3.75 centimeters squared times 2. Okay, so the area of my circles, and this is in actuality, will be 3.14 times 3.75 times 3.75 times 2, 88.3125. Now I'm going to leave my number here. I need to eventually round to the nearest tenth of a square centimeter. 88.3125. After I do all my adding at the end, then I will round. If I round already now, I probably will get it right, but there's a chance that it would be off, so we'll just leave it for now. All right, this takes us then to the area of the rectangle. Area of the rectangle equals, all right, well, we came up with that formula a little bit before, right? 2 pi r times the h, times the height, 2 pi r h, is equal to, okay, I'm going to use 2 times pi, lovely, times the radius, which was 3.75. I already found that out. Now, could I have used pi dh? Absolutely. 2 times pi times 3.75 times the height, which was 11 centimeters. Area of the rectangle is equal to, all right, calculator again, 2 times 3.14 times 3.75 times 11, 259.05. Now I can already compare this to what my estimates were, and they're not far off, right? 88.3125, that's a bit lower than 100, but I did a bunch of rounding up there. 259.05, well, it's not far off from 240. And here I did a bunch of rounding up as well. So, I rounded this down. This one I did round up, but this I rounded down as well. So, not bad. Now, my total area, which I have run out of room to show on my screen, but I'm going to add those two up. 259.05 plus 88.3125 centimeters squared. And I'll get that on my calculator. $259.05 centimeters squared plus 88.3125 centimeters squared. Grand total of 347.3625 in my calculator. Now I am told to round to the nearest tenth. So that's going to be 347.36. That rounds up to 347.4. How does that compare to my estimate? Pretty good. This tells me most likely I haven't made any calculator errors or like missing a decimal point or putting it in the wrong place, because that's often, if you're using a calculator, that's often where you go wrong. The other place people go wrong is they forget to square something, or they multiply by 2 more than once, goofy things like that. Show your work. That's going to make this whole process easier. Have fun. Assignment is here. Get at it.